In this video, we're going to be talking about our fourth and kind of final review topic before we get started into the algebra curriculum. Also, excuse my very deep voice today. I'm still getting over a cold. So today we're going to be talking about the distributive property and also combining like terms. Nothing we're going to talk about here today is stuff you haven't seen before, so this is all review. So if you recall, the distributive property is the one that allows us to multiply two things together when one of those things, in this case, are b plus c, right? So we're multiplying a times b plus c when one of those things has two parts. And so when we do this, it's simply telling us we're going to take the a times the b, giving us ab, and we're going to do a times c, giving us ac, right? Now, normally we wouldn't use a distributive property if we can actually add b and c together and get a number. Usually the distributive property is used when we have two things inside the parentheses that are unalike, so we cannot combine them together. And we'll demonstrate that shortly. And the distributive property works the same with subtraction, right? So a times b and a times c. This time, though, it's a subtraction question, and so we subtract the results. All right. You may also see it written, although it's not as common, but it means exactly the same thing, because I hope that you know that multiplication is what we call commutative, meaning you can multiply in any order. And so instead of having the a in front, a times b plus c, you can also just have the b plus c times a. And then I would just take and distribute the a as we just did. Okay, so if it's written backwards, it's going to feel a little abnormal, but it has the same exact meaning. All right, one way we can use the distributive property, and I use it this way occasionally, is we can make certain multiplication questions easier. So let's take a look at example number 1. Rewrite the following multiplication problems in terms of something that looks more like a distributive property. And I'll demonstrate on the first one and then ask you to pause and try B and C on your own. So if I'm going to multiply 4 times 55, I can obviously grab a calculator or I can work it out long way. But you could also try to find a way to turn 55 into the sum or the difference of two maybe easier numbers to do math with. For example, with 55, I'm going to think about 50 plus 5. So this says 4 times 55, but I'm just going to turn into 50 plus 5. Now, normally we wouldn't waste our time with distributive property, and what we would do is, if faced with this question, we would add the 55 and then we would multiply. But I want to demonstrate to you that this makes doing some multiplication questions easier, because now all I have to do is do 4 times 50, and that is going to be 200. And I'm going to do 4 times 5, which is 20, and so the answer is 220. Okay? And if I recognize that, there's a strong chance, and I could at least, I could just now do that all in my head. All right, and 4 times 55 is not that hard, but let's take now look at 13 times 102. All right, now I've got two-digit multiplication, and that's going to get annoying, and I don't really want to do it. And if my calculator's handy, I'm probably just going to grab it. But I could also do this pretty easy. And by the way, the answer is just going to be 1,326. And the reason I know that, I hope I'm right, by the way, is this problem can be rewritten as 13 times 100 plus 2. And 13 times 100, of course, is 1,300. And 13 times 2 is 26, so it's 1,326. It could also be used with subtraction. So when I look at 21 times 99, I will recognize, hopefully, eventually, thinking about it, that 99 is just 100 minus 1. So I can now just multiply this problem. And 21 times 100 is quite simple, as is 21 times 1. And now I just need to subtract those. So it's going to be 2,000, and it looks like 79, because 100 minus 21 is 79, I think. Okay, so that's just kind of a fun way you can use a distributive property, but most of the time in math, we will be using it a little bit differently. So let's take a look at example 2. All right. Most of the time when you are faced with a problem that you're going to use the distributive property, it's because you have this situation like we have on example 2, and 5x and 3 cannot be added together. We're going to review in a minute why that is, but we cannot add things that are not the same. So if we want to simplify this beyond what's written here on the page, our only option is the distributive property. Okay, and so we're multiplying 2 times 5x, and that's 10x, plus, and then we're doing 2 times 3, which is 6. Now, just like I can't add 5x plus 3 together, I also can't add 10x plus 6 together, and so this is as far as this problem can go. All right, part B, we're going to do a third times 3b. A third of 3 is 1. Hopefully we recognize that. And if you don't, just realize you're just multiplying straight across. So you get 3 over 3, which is 1. So that just leaves us with b. And a third times 2 is simply going to be 2/3. Once again, because you have a third times 2 over 1, and you multiply straight across. And 2/3 does not simplify. And that's it. That's the distributive property. There are little things we're going to get wrong. Like we're just going to forget in the heat of a question. You're going to go too fast. And the most common mistake is to forget to multiply the second one. Almost everybody will remember to do the first one, but we will occasionally forget to multiply by the second term. Boy, I bet my voice is getting pretty annoying by now. All right, example 3. Here's the other most common, and it is common. If you don't make this mistake, like ever in your life, then you are probably a superhuman, because everybody will make this mistake. And the way to combat that is to pay attention to it. So, looking at part A, we once again have a distributive property. And now we're going to multiply by a negative number. Okay, so just multiply by a negative number. So negative 2 times 6x makes negative 12x. And a negative 2 times a positive 4 makes negative 8. I'm just going to call it minus 8. Okay, because it means the same thing. And we're done. Can't add those together, so do not try. Unlike things cannot add together. All right, our next one, we're going to multiply negative 2/5 times 3. And so, again, we multiply straight across. I hope you don't have to write it eventually, but if you need to see it, right, see the 1 under there. So that's going to be negative 6/5 x. And then a negative times a negative, right, as we multiply here, makes a positive. And there's going to be our biggest error. We're going to forget that or not notice it. And I get 2 times 1 over 15. And that's as far as we can go. And in this case, I would consider this also a distributive property because we don't see it. But what we really have here is a math question. You can think of it as a negative 1 times negative 2x plus 7. So if it helps you to think of it that way, you can always view just a negative all by itself like that as negative 1. So a negative times a negative is a positive, and I get 2x. A negative times a positive is a negative, and I get 2x minus 7. All that did was change the signs of both of the terms inside. And that's all there is to the distributive property. As long as you're paying attention to all the negatives, then it should go fine. All right, let's talk briefly about combining like terms, which again is nothing new. When we are adding and subtracting, well, first let me back up. We need to talk about what a term is. An actual definition, but we'll make it easier than this, could be just a number, could be just a variable, or it could be a combination through multiplication or division, I suppose, of a number and a variable. So, for example, I have what's called a polynomial here on the screen. We'll talk about that later in the year. And we have what would be called 4 terms, because a term is separated by positives and negatives. So remember, a term is a number or a variable or the product of a number and more than one or more variables. So in other words, this piece right here is term 1. The minus separates it. So this is, ooh, that was not a good one. Let's try that again. This is term 2. This b all by itself, because remember, a term can just be a variable itself. This would be number 3. And then this constant by itself is term number 4. So I would say there's 4 terms here. More definitions. You're going to hear this word a lot, and it'd be great if we know what it means. Coefficient. Coefficient. The coefficient is the number portion of a term. So when I'm looking at 6a squared, I would often, you're going to hear this question, well, what's the coefficient? And the answer to that is 6. It's the number portion. The coefficient on this term is 5. The coefficient on the third term, and I want you to think very carefully about this because this is another thing that's going to come up all year long, and it'd be great if we didn't have to explain it every time. When we look at a b, there is a number being multiplied by b, but since it's not there, we can imply that it is a 1. There's a 1 times b here, and the reason we don't see the 1 is because 1 times b is b. So it'd be redundant, it'd be unnecessary to write the 1b. You can write it. Most mathematicians, like once you get to a certain understanding of math, would never do that. But for Algebra 1 students, if you want to write a 1b, that's fine. And so the coefficient on this one would be just a 1. And this would be a coefficient of 12. Okay? All right. Now, when you are trying to combine like terms, or when you're adding and subtracting, when you're looking at terms, like terms are the ones that have the same variable factors. Okay? So this guy over here has got some a's in it, and this one's got some a's in it, but this one's got a times a, this one's got an a times b. They're not the same. If it was a squared and a squared, they'd be the same. If one was ab and the other was ab, they'd be the same. Okay? So let's now go down and kind of talk more about combining like terms. So I've just tried to illustrate for you what I just said. 3x and negative 2x are like terms. The numbers are different. That doesn't matter. It's the variable portion. We have a 5x squared, a negative 5x squared, and a 9x squared. Since they both are x squareds, they are like terms. xy's with other xy's, x squared y cubes, x squared y cubed. So all of these rows are numbers that we could actually add together. And in fact, why don't we go ahead and do so? Let's go ahead and let's imagine there's a big plus sign in between all of these. Okay, so we're going to add 3x plus negative 2x. So 3x plus a negative 2x. We know positive and negative. A better way to write that would be 3x minus 2x. And 3x's minus 2x's leave you with a single x. And that's how you should think about them. Think about them as objects. This is literally saying I have 3 objects and I'm going to take away 2 of the objects. So now I have 1x, right? One of the objects. We don't change the powers. We're just counting objects. So this next one says negative 5x squared plus 9x squared. So the answer is going to be whatever negative 5 plus 9 is, which is 4. So the answer is 4x squareds. Again, think of them as objects. Negative 5 of the objects plus 9 of the objects makes us a total of 4. Xy minus 3xy's. So again, just think of xy as an object. It's the newest whatever. And we have one of them, right? 1xy minus 3xy. So the answer is negative 2xy. And finally, the last one, we've got negative 7x squared y cubes. And I'm going to add 15 x squared y cubes. And so the end result will still be x squared y cubes, and the coefficients are just negative 7 plus 15. So that's 8. And that's it. All right, our final example, example 4. Now we're going to kind of practice both concepts today. So we've got just some basic combined like terms, and then I've got some, if you'll notice on like D and E, that include the distributive property. So pause the video, please, and try these on your own, and then come back and see how you did. All right, so the top row hopefully is pretty simple. It's what we just talked about. This is 3x squareds, and you have 5 more x squareds. That's going to give us a total of 3 plus 5, 8x squareds. The temptation that you're going to have is to change x squared into something else. But that's not how addition works. This is, again, think of it as an item, okay? The new phone is called an x squared, and you have 3 of them, and your friend has 5 of them. And so you put them all out together, you have 8 of them. They didn't change into something else. There's just 8 of them. 2x minus 9x is going to simply be 2 minus 9, which is negative 7, and there's still x's. All right, on part C, we have to make sure we only add common terms together. So I look at this problem, and I see that I have a 5c and a 2c. So you can rearrange this if you want, if it helps you. But essentially what you're going to want to do is you're going to want to ignore everything except for what you are combining together. The difference is we have to pay attention to the signs. This negative right here, that subtraction, that negative, however you want to think of it, it belongs to the 3. This negative right here, it belongs to the 2. This plus belongs to the 6. So you have to pay attention to that. So when I look at this and I see, okay, I've got 5c, oh, and here's some more c's. I've got to grab that subtraction with it. It's a 5c minus a 2c. And so that would be 3c. But you'll notice now I can also combine a negative 3 and the 6 together. And what we need to think about is who owns this minus sign right here. And so who owns it? The 3 does. So this problem becomes a negative 3 plus a 6. And negative 3 plus 6 is 3. So the answer is 3c plus 3. And that's going to be a big issue for some of you, is you're going to know that you need to do what we just did, but when you do the 3 and the 6, you're not going to bring the negative with it. Okay? Some of you might be having issue with me calling that a negative instead of a subtraction. Well, here's the quickest way I think I can show you that you can use them interchangeably. Let me rewrite this problem. 5c minus 3 minus 2c plus 6. All right. On one hand, we could do this. I'm just going to do part of it. We talked the other day that we could rewrite 5c minus 3 as 5c plus a negative 3. Because a positive and a negative together mean subtract. So when I say this is negative 3, I'm basically shorthand doing what we just did. I'm treating all of them as if it's addition, and I'm just seeing that this is really 5c plus a negative 3 without writing it down. So shorthand, if you're going to do something with the 3, you can visualize it as a negative 3, and so like that. All right. But the easier way just to demonstrate that you could call it one or the other is what happens if you read this right now. It says 5c minus 3, right? Well, what happens if I erase the 5c? Now what would you say? Now you would call it negative 3 minus 2c, right? So the fact that the 5c is here makes us feel like it's a subtraction. But if I were to remove it, now it looks like a negative. That's another way you can kind of just tell that you can treat them as the same thing. All right. I hope that makes sense. All right, let's do the last two. All right, in this one, we have a distributive property. In a perfect world, again, order of operations, we would go inside these parentheses, right? But inside those parentheses, there's nothing to do because I cannot add them together. And that's why we need the distributive property. So I cannot do anything inside. So then the next piece of order of operations would be I have to multiply before I worry about subtraction and addition, right? So the multiply comes first. And in order to multiply, I have to distribute. So I get 12x minus 8. And then I write the rest of it down. And now we're kind of like we were on the last example. I have two pairs of things I can add together. So ignore the one while you do the other. 12x minus 7x is, I believe, 5x. And then I have a negative 8, right? Negative 8 plus 12 is positive 4. So I get 5x plus 4. All right. If you wanted to, you could rearrange it, and as long as you move the signs with it. So, for example, if it helped you, you could put the like terms next to each other. So, if you wanted to rewrite this problem, you could write it as 12x, and then let's move the 7x next to it. But don't forget, the negative, the subtraction belongs to it. So, I've got 12x minus 7x. And then we've got the negative 8, the minus 8, plus 12. So you can rearrange them to if it helps you. But again, anytime you move a number, you got to take the sign in front of it with it. All right, but usually that's not necessary. And our last example. All right, we got to be very careful here. Again, I have some parentheses, so I go inside the parentheses and realize in both of them there's nothing to do. So now I'm going to move out and see what operations I have. I have an addition. I have a multiplication right here. I have a subtraction. And I have a multiplication. All right. So we know the multiply has to come first. But many of us are going to look at this, especially if they were little smaller numbers, and you're going to want to do 5 plus 6. You're going to want to do it. And I get it because it looks really easy. It's sitting there. But we know the order of operations says I have to do this multiply before I even worry about adding anything. So that's what I have to do first. So I'm going to do the 6 times the 2. So I'm going to write down the 5 plus 12x. But I also have to do 6 times negative 4, giving me negative 24. All right. Now, here is 100% the biggest mistake you will make while doing this math. You will otherwise know what you're doing, but you'll make this mistake over and over and over again until you pay attention to the detail of the subtraction. So, once again, there's an argument we could make that this is a minus sign. There's an argument to be made this is a negative sign. And you get to use it however is most convenient to you. And here's how I can quickly again describe for you that this can be treated as a negative. If all of this goes away, it no longer looks like a subtraction. Now it just looks like a negative. And that's how I want you to treat this. Since I'm doing a multiplication with this 7, and what did we say earlier? That the sign belongs to the number, then I should do a distributive property with the negative as well. So negative 7 times x is negative 7x. Now it looks like a minus 7x. Same thing. And a negative 7 times 3 is negative 21. Now our job is simply to combine like terms. I generally like to do my variables first, but it doesn't really matter. So I see I have a positive 12x and a minus 7x. So 12 minus 7, positive 12 minus 7 is 5x. So that's taken care of. Now I just need to focus my attention on what's left. 5 minus 24 is negative 19. So I'll just do this in 2 steps. So that makes negative 19. And then I still have a minus 21, leaving me with an answer of 5x minus, and if we add those together, we get 40. They're both negative, right? So negative 19 minus 21 is negative 40. It's not 19 minus 21, it's negative 19 minus 21. Okay, lots of room for silly mistakes, but the concepts themselves are quite simple. So focus on the silly mistakes since the concepts will take care of themselves. All right, if you have questions, come see me during student support time.